Section 2.1 concerns rational numbers on a number line. The very first thing we have to do is figure out what rational numbers are. We are going to talk about classifying numbers. Every number that you have talked about so far in your math career falls underneath the category of real numbers. When you get to Algebra 2, you're going to meet something called imaginary numbers. So up to that point, you can assume that any number that you talk about is going to fall underneath the category of real numbers. Under real number, we have two distinct types of numbers. One is called an irrational number, and the other is called a rational number. Now, if you remember right, what we just said was this section has to do with putting rational numbers on a number line. So let's talk about the difference between rational and irrational numbers. An irrational person is someone who is not predictable. So like a young child at the age of 2, you go into a grocery store and they want a candy bar. And one day when they ask for the candy bar, you say no, and they're okay with it. The next day, maybe they haven't had a nap and they ask for the candy bar and they throw a temper tantrum. You can't predict how that child is going to respond, so they are considered to be irrational. Someone who is rational, they're very consistent in their behavior. Maybe they're always happy or they're always sad, but they're rational. So an irrational number might be something like 1/7. If you took a calculator and divided 1 by 7, you would get a number that goes all the way across the screen of the calculator, and you wouldn't be able to predict what's going to come next. So they are irrational numbers. If you've ever heard of the term pi, pi is an irrational number. It continues on forever and ever. We're going to focus over here on this side, rational numbers. Like 0.25 is a rational number. What comes next is a 0. If I have the fraction 3/4, that's a rational number. That's the same as 0.75. What comes next would be a 0. If I have 1/3, that is a rational number because it's a repeating decimal. And so if I have 0.3 with a repeating line over it, I know that the next number is a 3 that comes after that. The very smallest unit of rational numbers that we have are called natural numbers. I'll just put that, and I'll put natural down here. Natural numbers begin with 1, 2, 3, and then they continue on forever, but they're whole numbers beginning with 1. Outside of the natural numbers is what we call whole numbers. Now, whole numbers include, and I'm going to underline that O there, because whole numbers are just like natural numbers, but they include a 0. And then they continue on forever. Outside of whole numbers, we have a category called integers. Integers are positive and negative whole numbers. So not only do they include all the positive numbers, they include the negative numbers. But again, see, and they continue on forever. You don't have fractions, you don't have decimals, unless perhaps the fraction would give you a whole number. So if I asked you to classify 6/3, 6/3 is the same as 2. So it is the very smallest unit we find it in. It would be a natural number, a whole number, and interesting enough, the abbreviation used for integer is a Z. The abbreviation used for a rational number is a Q, and then the abbreviation used for the real is R. So it would be a natural, a whole, an integer, a rational, and a real. So that is classifying numbers. We'll get more into that in a later section. But what we're going to do today is we're going to take this side and we're going to work on putting those on a number line. So if I need to identify points on a number line, that means they're going to give me a number line. And they might, let's see. Let's say they've got that, okay? Then that means that the points on this number line are -3, 1, and +3. Occasionally what they do is they give you a number line and they like highlight or deepen in color one side. So let's say I have 0, 2, and that's a deeper color. Then what I have is I have the set of numbers that look like this. So it's 0, 2, and then there's more highlighted numbers after it. We're going to assume that this is going to be even numbers from 0 and above. So let's say they want me to do just the opposite, and they want me to graph numbers that they've given me on a number line. So if I have like numbers that have fractions in them, I'm going to be more specific on a number line. This one has half, so probably I'll go -1/2, -1, +1/2, +1. So I would want to put a dot on the -1/2, put a dot on the 0, and put a dot on the 1/2. This one, if you'll notice, has the continuation dots. So that means I'm going to highlight or darken the one side. I might want to do more specifics here. I might do -1/2, -1, and -1.5. I might do +1/2, 1, and 1.5. So I would need to highlight or put a dot on -1.5, a dot on 0, a dot on 1.5, and I would need to darken that arrow right there because that continues on in that direction. All right, this one. Notice it's divided up into thirds. I have negative thirds, I have positive thirds. So I've got 0, I've got -1/3, -2/3. If I have -3/3, I have -1, and then I have -4/3. Going in a positive direction, I have 1/3, 2/3. Again, 3/3 is the same as 1, 4/3, and 5/3. So when I highlight these or put a dot on them, I have -4/3, -1/3, +2/3, and 5/3. So that would be putting the rational points on the number line. This is taking a number line and selecting the rational points. If I had one that said just I want to graph all integers less than -6 and greater than or equal to 1, remember integers are positive or negative whole numbers. So I would graph these. All right, so an integer less than 6, the very first integer that I come up to that's less than 6 is my negative 7. And then I would need to highlight that in because it's graph integers less than. So there's a ton of integers that are less than negative 6. So I need to show that on my graph. And then, or greater than or equal to 1. So I can highlight this. That's going to be 1. If I want to put a 2 there, I can put a 2 and highlight that one too. But it's going to be all of them that are greater than or equal to 1, so I would also need to make that arrow darker. So this is integers less than 6, beginning with negative 7, or greater than or equal to 1. So I graphed a couple here, and then I'm going to highlight the end. All right, absolute value is another thing that we find in this section. And absolute value is the number of units a number is from 0 on a number line. It's always positive. So the absolute value sign are two parallel lines. So the absolute value of negative 7 is positive 7. Because if I had a number line like this one up here, it is 7 units away from 0. 1, 2, 3, 4, 5, 6, 7. So the absolute value of negative 7 is 2/3. Or is 7. If I'm going to take the absolute value of negative 5/8, that's going to be positive 5/8, because negative 5/8 is 5 units away from 0 on a number line. The absolute value of positive 0.25 is still 0.25, because the absolute value means the distance 0.25 is away from 0 on the number line, which is 0.25 units. So remember, absolute value is always going to be the positive of whatever number you find inside there. They're going to take the absolute value and they're going to put it in algebraic expressions, and they're going to have you substitute a number for it. So here you're saying evaluate 15 minus the absolute value of x plus 4, and then they're telling you x is equal to 8. So I'm going to plug this in. I have 15 minus the absolute value of 8 plus 4, and I know that 8 plus 4 is 12, so I have 15 minus the absolute value of 12. The absolute value of 12 is 12, because 12 is 12 units away from 0. So I'm going to get an answer of 3 here. All right, I'm going to plug this one in. I have the absolute value of 12 minus 8 plus 5. 12 minus 8 is 4. So I'm taking the absolute value of 4, which is positive 4. So 4 plus 5 is going to equal 9. So when I evaluate that one, I get an answer of 9. All right, your homework on this section, section 2.1, is page 71, 18 through 54 even.